welcome to Pale Blue Pod, the astronomy podcast for people who are overwhelmed by the universe but still want to be its friend. I'm your host. I'm Dr. Moiya McTier. I'm an astrophysicist, a folklorist, and a best bud to the universe. And today I'm joined by hopefully a new friend to the universe. I'm joined by a stand-up comic and comedy writer. Welcome, Chris Cook.
Hello, Dr. McTier. What do you prefer? Doc,
You,
Doctor, Moya? What do
oh,
you want?
Doc would be fun.
Doc, we can do Doc.
I
Doc
like
Mick, I
that.
like it. Yeah, let's do it.
Chris, how you doing today?
I am great. How are you? It is another awful, chilly day in Chicago.
Mhm.
So I am wrapped up here in my cozy little location and ready to get my mind blown here.
Yeah, I love it. Can you tell the listeners a bit about where we are today?
Yeah, so I recently, not to brag, sick brag, bought a new home with my wife.
Sick.
So sick. So I am currently in my oldest son's playroom. I thought that was, the best place of wonder that, I could let my mind, play around a little bit. So we're in here, we're doing it. I actually brought a friend. I know this isn't a fully visual podcast, but I thought this would maybe help me.
Yes, yes, we all need a little Buzz Lightyear
you
companion.
know, Buzz power, So
I love how you've turned this into show and tell.
yeah. Going with the vibes of the child playroom. So, I thought we'd roll with it.
Yeah, the whimsy vibes are strong. I love it.
Absolutely.
So today we're talking about a system of planets that neither of us have ever visited. Maybe Buzz has. Who knows?
Yeah.
Uh, Today we're talking about the TRAPPIST-1 system, and I'm curious because you picked this topic. What drew you to TRAPPIST-1?
I mean, just the mere fact that it sounds absolutely bonkers, that was enough to pull me in. I mean, I read a really brief description, but this was, a couple of weeks ago, and I also, another sick brag, recently had another child. So,
Congrats.
thank you. So my mind is just completely scrambled. So I thought this would be a perfect time to, try to understand a completely other universe. Why not?
I think that makes sense. When you are forced out of your normal modes of thinking, that's often a good time to learn something new.
100%. Let's dive in. I don't have enough going on, so let's do it.
I know. Yeah, you don't sound busy at all. So
No,
let's
no,
talk
all
about
good.
space.
Let's do it. Let's do it.
Okay, but before we talk about the TRAPPIST-1 system, I do want to know a bit more about you and your relationship to different spacey things. So I have a little preliminary exam. It's a get to know you quiz with no right or wrong
Oh
answers.
God, not multiple choice, unfortunately.
No. No, there used to be some like A or B questions and I took them out.
Okay, I
Hmm.
feel like that's kind of how I got through college was multiple choice, but we'll see. We'll see how it goes. Let's do it.
Okay. Question number one. How would you describe your current relationship status with the universe?
Oh wow, starting nice and light, huh?
Uh-huh. Yeah.
I would say imbalanced.
Ooh.
The universe, kind of just seems like it's given us everything we have, and we are just kind of flushing our planet down the toilet, it seems like at this point. Not to get all philosophical and political to start off, but it's I guess if we were in the office, we would be Ryan and the universe would be Kelly. I'd put it that way.
Like the Office, the show?
The show, correct. Yes.
Oh, why am I not remembering who Ryan and Kelly are? Oh, wait. Who are Ryan and who plays them?
BJ Novak is Ryan
Hmm.
and Mindy Kaling is Kelly.
Oh, okay. There you go.
That whole relationship seemed just totally toxic.
Hmm.
One is way more in than the other. And I feel like that's just kind of where we are right now.
Wow, you're so right. I like that you have acknowledged that the universe has given us so much. That's nice.
Everything, right? I mean, we wouldn't be here without it, I would assume.
That's very true. I hope that we can become less toxic with the universe going forward.
I agree. I agree. We're on a great track right now. We're just such a, stable, untoxic environment we're living in. So this is perfect.
Yes. Okay, question number two, maybe a little bit lighter of a question. Do you have a favorite equation?
Favorite equation. Anything that I could solve,
Mm,
which really, really whittles down our options. If we're kind of sticking in, the addition area, I'm golden.
sick.
Anything past that, subtraction, multiplication, maybe, but
Mm,
division, it's a no-go. So, throw me a good 7 plus 2. That's me. That's where I'm sitting. I love it.
okay.
That's my favorite equation.
So, addition's a good one. Subtraction is where it
Yeah.
starts to get weird. I remember that getting confusing in elementary school. Yeah.
I'm a giver. I'm not a taker. I'm a giver.
Addition, it's the mathematical tool for all the givers out there
It
in the
is
world.
the
Great.
generous equation. Yeah.
All right, next question. Do you feel like your zodiac sun sign fits who you are as a person?
Ooh, okay. So this is where I have some blind spots. You might have to help me out here. So
Hmm.
I was born in July, which I believe makes me a Cancer, correct?
I have no idea. I'm not an astrologer.
Okay. Well, I think that's what I am.
Okay.
And I don't know, again, much about astrology. A Cancer, it doesn't seem like the greatest name for your sign.
It
Like I've
doesn't.
been called a Cancer in many environments, but I don't think it's a direct application to my astrology sign. So that's, I guess, kind of where I land. I don't think I'm a Cancer
Okay.
in personality, but I guess in astrology I
Okay. Interesting. Yeah, I don't know anything about the
am. Okay.
stereotypical traits associated with cancers. I do know that the Cancer constellation is one of the oldest constellations we have. We can trace it back
Oh,
to the ancient Babylonians and the constellations
okay.
that they put in the sky. So, at least you're one of the originals.
I mean, it checks out. Again, sick brag, in July, I turned 36 years old, so I'm feeling very old. Things hurt that
Mm,
have never hurt before. I'm sitting this way for a reason, for my back. Yeah, so maybe it does check out. Maybe it does work.
yeah,
Yeah,
like some parts of it, let's say that.
sure. Just like my body, some parts work, some don't.
That's nature for you.
That's right.
Chris, what do you think is the best planet?
Ooh, um, Captain Planet. Remember that show?
Not expecting that. That's
I
so good.
mean, how about that? Like an environmentalist superhero? Like you can't beat it, you know?
Yeah. Did they ever make a show or was it mostly comics?
I remember the show from when I was a
Cool.
kid. I remember it was, I don't remember the whole theme song, but I think it just started with Captain Planet, he's our hero. And then I don't know where it went from there. I don't know if we run into any trademark issues with that, so we may have to cut it. But no, for real, I guess real planets.
I think that was a great answer though, but sure, you
Okay.
can give me something real if you want.
I mean, Neptune. Like, why do I feel like no one talks about Neptune? Like, what do we know
Hmm.
about Nepi? What can you tell me about Neptune?
You're right. People don't really talk about Neptune because it doesn't
Yeah,
have any superlative characteristics. It's not the biggest. It doesn't have the most rings. It's not
yeah.
the most extreme in its tilt.
Where's it at? Like, what number is it?
It's number 8. Although
Okay.
sometimes Pluto, and the official stance of
Mm,
Pale Blue Pod is that Pluto is still a planet, just like a special category of planet.
okay.
Pluto sometimes orbits closer to the sun than Neptune. Like occasionally it dips in closer.
So why was it the ninth? Is it? I mean, is it more often further away from the sun than?
Yeah,
Okay.
it's only
Okay.
like
That makes sense.
for 10 years every like 100 years or more that it
Mm,
changes. Hmm.
just a drop in the bucket. Just a
Really?
drop in the bucket. Yeah.
You'll see that trend with space, that like all of
Okay.
the time scales, all of the distance scales that we normally think of, it's a drop in the bucket compared to the universe.
Sure. Makes total sense.
Okay, well, I think that both of those answers were fantastic, and any sort of copyright or trademark issues aside, I do want us to start thinking about music. So
Yes.
imagine you're an astronaut going on a mission into space and you're strapped in, ready to blast off. What song are you playing during your launch?
Ooh, that's a great question. Launching to space. How about Into the Mystic, little Van Morrison? How
Ooh, I
about
don't know this
that?
song, but I do enjoy
Oh,
some Van
okay.
Morrison songs. Okay.
Yeah. So, I mean, obviously, pretty directly the title applies to it, I suppose. But I think the song like talks about the sun and like the wind a little bit. I think there's something in there about, smelling the sea, touching the sky. Like it's all just kind of one big song.
Hmm.
To quote one of my favorite bands, the Grateful Dead, it's all just one big song.
And the universe is too. It's all just one big
Yeah,
song with lots of harmonies inside.
absolutely. 100%. So yeah, let's go with that. Let's go with Into the Mystic. Van
Into the
Morrison.
Mystic.
Shout out.
I'm gonna check it out after this recording.
Please do. Please do.
Okay, awesome. This is actually just my ploy to get new song recommendations from people.
Oh yeah, I'll fire you over my Spotify. I just
Cool,
got my
thanks.
Wrap today, and it's absolutely embarrassing having children who. I think my top song was "Cruel Summer," but and I'm not here to fuck with the Swifties. I bow down. I'm not here, but I've listened to "Cruel Summer" in the 2024 more times than maybe even the actual Swifties have, solely because my 3-year-old son is obsessed with it. It's Cruel Summer and it's Hot to Go by Chappell Roan are the two biggies. And then randomly, we don't talk about Bruno from Encanto. So just
that makes sense,
three. Yeah, that makes the most sense, but not a whole lot of, synergy between the three of those. But
I feel like Wrapped needs a little toggle where you can say, like, I have young children.
Oh my God. Perfect. That is such a great idea.
Spotify, get at us.
It's like you're a smart person or something.
Okay, well, I will put that on the playlist. I'm keeping track of all the songs that people recommend.
I love it.
Next question is imagining that you can go anywhere in space and anywhere in time. What type of event would you most want to witness? And you're completely safe the whole time.
Okay. I mean, let's go back to the OG, the Big Bang, where it all started. Like, put me in stadium seating a little bit further away just to avoid any shrapnel. But yeah, let's see what went down. I think that would be great.
Scientists would thank you. You would win so many Nobel Prizes. You would be famous forever.
All I would have to do is just record it on my phone.
Yeah.
Like I wouldn't have to, take any notes or anything because I'd be the only one with it.
Right.
I would sell out so fast if I had that footage. It would be incredible. It would be unbelievable.
I'm wondering who would want to buy that, though, aside from like NASA.
I mean, I don't know. Like, there's so many people with fuck you money with just, the Musk.
Elon Musk would buy it so that he could
Jinx.
lie about it to people.
Yeah, he would say he was there. He would say he was the one that would do it. Again, I'm sure Elon is tuning in right now. Please don't sue. We're here. We're just having some fun.
Elon, don't sue Chris. But I fucking hate you. So do whatever you want. I don't care.
Well, see, the way you frame that, you're putting that on me now. You said don't sue Chris.
Don't
Elon,
sue Chris.
Fuck you.
Okay. Moiya McTier, hate you, Elon Musk.
Okay. Well, listen, me and Buzz are with you. We stand with Doc. We stand with Doc.
Thank you. I'm rallying a team. The Big Bang's a great answer.
Okay, perfect. Yeah, it sounds great.
Yeah, I would love to see that. It's something that we cannot see because the photons were too scattered early in the universe to escape to us. So we call it like the Dark Ages.
Yeah, I mean that checks out. Out.
All right, final question in the quiz. Yeah. What do you think is scarier than a black hole?
Oh my God, that is terrifying.
Maybe nothing is scarier than a black hole. I don't know.
No, there is something, and I'm currently dealing with it. I'm a warrior, and I cut my pointer fingernail too short this week.
Oh, no.
And it is painful. It's terrifying, and I would rather be in a black hole than feel this pain on my finger.
That's a particular type of torture.
It is.
Like you can't, you did it to yourself.
I know. It's and I'm not a masochist. Like not to get too graphic. I don't like pain, in the boudoir or anything. It's not for me. It's worse than a black hole. I would rather be sucked into a black hole than have too short of a pointer finger nail.
But any nail, right? Like it's not just the pointer finger.
Yeah, but I mean, it's one of those things where you don't realize how much you use it until you feel an effect on it, It's like the thing where if you have one stuffed nostril, you don't realize how good you had it when you had two. Like it's one of those things.
It's all relative.
It is. It's all one big song.
Awesome. Well, I feel like I know you a little bit more now. I feel like I have a sense for where you would fit in the podiversity here once you matriculated.
Janitor's closet, probably.
No. We're gonna put you in probably like the comics class, not comedian comics, but like the drawing comics class. Because of your Captain Planet answer, that's
Yeah,
that's for
it
the
was a pretty dope answer. I'm not gonna lie, it was pretty sick. It was a pretty great answer.
It was one of my favorites so far.
Oh, good. I like it.
Everyone's naming real planets. Like, what are you talking about?
Let's think wider. Let's think bigger. Let's think outside the box.
Speaking of planets, we are here to talk today about a system of 7 exoplanets that was discovered in 2016, 2017, around that time. We're talking about TRAPPIST-1. And you said you did like a very, very brief search on it.
Yes.
So what do you know and what do you want to know by the end of the episode?
What you just briefly said is essentially what I know. I saw the word exoplanets and I was like, all right, that's it. That's past my brain.
Awesome. Awesome. Okay. And what is something you would like to know by the end, aside from what an exoplanet is?
That was going to be my answer. You stole it. Is there any chance that it would come like in contact with us? That's probably the dumbest question ever, but
That's not a dumb question at all.
okay.
I wrote my PhD dissertation on that question, so that's not dumb.
Holy smokes. Okay.
Not specifically about the TRAPPIST-1 system, but about systems
Okay.
getting close to each other. Yeah.
Yeah. Okay,
I can
cool.
answer that now. No, it's not going to come anywhere near us, and it would take us several, probably like 1,000 years to get there. So
Okay.
probably no interaction, but we can study it from afar, just like we can all exoplanets. And exoplanets are planets that orbit stars other than the sun. So it's extrasolar planet outside of the solar system.
Okay. Got it.
Hmm.
And you mean outside of like our solar system?
Hmm.
Got it. Okay.
Yeah. Technically, ours is the only solar system because our sun's name is Sol. And when we're talking about other
Ah,
systems, if you're being like a pedantic asshole, then you should say
mm,
stellar systems.
okay.
Yeah.
You know who says that? Elon Musk. He
Yeah.
says stellar systems, I bet.
Yeah, he does. He does.
Yeah, for sure.
Okay, yeah, so we learned about this system of planets in 2016, 2017, but I want to take us through a timeline of the discovery of TRAPPIST-1 starting in 1664. We're going really far back. So in 1664, I feel like you don't see this coming. An order of Catholic monks split off from the Catholic branch Cistercians at a French abbey called La Trappe.
Okay.
And I love that there is this line between an order of Catholic monks in the 1600s and the discovery of this system of planets.
Yeah.
Um,
Monks in La Trappe. Let's go.
Monks in La Trappe, yes, and they
Yeah,
they called themselves Trappists, but there were also nuns who were Trappistines, which is very fun. I guess it was
that's fun.
in
Yeah,
some ways a more progressive monastery.
sure.
But their branch moved around Europe to Switzerland and to Belgium, and they spread that way. But the Trappist religion really valued manual labor. So all of the Trappist monks spent a lot of their time when they weren't praying doing things like making bread and making wool and making cheese and also making beer.
Sounds like the pandemic,
It does, yeah.
you
I
know,
mean, really, yeah, we all kind of turned into monks for a few months.
for sure. For
Oh,
sure.
you're so
I am
right.
bald, but I let my thing grow out. So I really got in. I let my cul-de-sac go. I call it the cul-de-sac. I
We should bring that back. That was a hot look. I think we should bring it
Yeah,
back.
the George Costanza. Why not?
Have you ever had Trappist beer? Are you a beer drinker?
I am a beer drinker, but I have never had Trappist beer.
It is a pair. I'm not a beer drinker, but
Okay.
I have been around people who consume it, and I've often heard them talk about Belgian beers. And one of the most
Yes.
popular Belgian beer brands is Trappist. And so
Okay.
this got connected to the telescope because when they originally planned this telescope to look for exoplanets, to look for planets outside of our solar system, it was a collaboration between Belgium and Switzerland. And to harken back to like a cool contribution that Belgium has given to the world, they named this telescope after beer making monks.
Chocolate and beer. What else do you need?
No notes.
That's
Um,
right.
so let's fast forward to 1999. This is when the star that the system orbits was first discovered. So it wasn't originally called TRAPPIST because the TRAPPIST telescope didn't come into operation until 2010. Originally, it was called this like really long string of letters and numbers, but it was a two-mass object. Two-mass was like a survey of the local region of the universe, so it included a lot of stars, and it gave them these designations. And it was one of the smallest known M dwarf stars. Have you heard of the term M dwarf?
No, I haven't. Put me
Cool.
on.
Cool. These are actually the most common stars in the universe. About 70 to 75% of stars in the universe are these M types. They're much lighter and much cooler and much dimmer than our sun. So when I say light, I'm talking about mass.
Oh,
Um,
okay.
Yeah, so it's a lot less massive, it's a lot cooler, and it's a lot dimmer than our sun. And this is one of the smallest, coolest, dimmest M dwarf stars that we had discovered. It's about 10% the size and mass of the sun. It's essentially like just a really dense Jupiter. It's this
Okay.
about the same size as Jupiter, but there's a little bit more mass in it.
Are stars on an alphabet system? Is it a, all the way through?
It is, there are letters, but it doesn't flow through the entire alphabet. There are seven
Okay.
of them from brightest and biggest to dimmest and smallest. It goes O, B, A, G, K, F, M.
Makes total sense.
Right.
Yeah.
I do have an episode where I talk about the different stellar classification schemes and how we got there, because this system with all of these different letters is based on like several people piling work on top of what came before them and getting rid
Sure.
of weird parts of other schemes and just like
Sure.
adopting things that didn't make sense. So yeah.
Okay. Yeah. Checks out.
So this star that eventually became known as TRAPPIST-1 is about 3 billion years older than our sun. So it's about 7.5 billion years old, which is really good because what we know about M dwarf stars is that when they're young, they're really magnetically active. And magnetic activity, while exciting, is probably not the best for life. It could probably strip away some of the atmospheres around these planets. But this star is old. It's had time to calm down. It's not as magnetically active anymore. So the planets could have more of a chance to hold on to their atmospheres now.
Okay. So it's kind of like a human, when you're young, you're a little more active and you're moving, you're shaking. And then, you get older and, you turn 112 and then you become president all of a sudden. And then, you
Yes.
slow down and, things chill.
Yeah, yeah, stars, they're just like us.
How about
We
it?
actually, there's another method for determining the age of a star. It's called gyrochronology. We're essentially looking at how fast the stars dance and like how fast they spin around. And when they're young, they're much faster, and then they lose their energy and their momentum as they get older, so they start to dance more slowly. And I
Okay.
love that. Just I'm
Yeah.
imagining a bunch of like seniors dancing at a
Yeah,
at a
for
party.
sure. For sure. At like a retirement home called like Starshine Communities or something like that.
Yeah, yeah. The tagline is something like, just because you're dimmer doesn't make you any less bright in our hearts or
Yeah.
something.
Just because you're dimmer doesn't mean you can't shimmer.
Yes, that's it. You got it. Hey friends, it's me. Buzz Lightyear took Chris for a quick trip up to the International Space Station because Chris has never been and he wanted to check it out. So I figured I would use this opportunity to share some messages with you. The first message is a podcast recommendation. It's a new show in the Multitude Collective and it's called Tiny Matters. It's the other science show on Multitude. You can dive into genes, microbes, and other tiny things that have a big impact on our world with Tiny Matters. Join scientists Sam Jones and Deboki Chakravarty as they take apart complex and contentious topics in science and then rebuild your understanding of them. From deadly diseases to ancient sewers to forensic toxicology, Sam and Deboki embrace the messiness of science and its place in the past, present, and future. Tiny Matters releases new episodes every Wednesday, and it's brought to you by the American Chemical Society. It's a nonprofit scientific organization that connects and advances chemistry and the broader scientific community, but Tiny Matters is not a chemistry podcast. I've had many conversations with Sam about this, so even if you're not the biggest fan of chemistry, there is a lot of really cool information waiting for you at Tiny Matters. So subscribe to Tiny Matters today wherever you get your podcasts. New episodes come out every Wednesday. All right, now I'd like to thank my patrons who support the show financially every month. I really couldn't make this show without you, so thank you all so much. And thank you and welcome to my newest pre-main sequence star, Jamie. Congratulations on collapsing your gas cloud, Jamie. I'm so proud of you, and welcome to this awesome club. A huge special thank you goes out to my sun-like stars, Scott Reynolds, Augustin, Tom T, Mark Mahoney, and Nicole Bartlett. I appreciate you all so much. You're golden, and I love being in your habitable zone. You too can hear your name on the show if you're not already one of my patrons. You can make it onto my patron star chart and get research notes for most episodes by joining my Patreon for $5 a month. Brighter tiers like my sun-like stars get access to Pale Blue Pod at night, where I just started reading The Arabian Nights in what I hope is like a slow, soothing voice to help people calm down and maybe fall asleep. So sign up now at patreon.com/palebluepod. I even offer annual memberships. So if you sign up for a whole year up front, you end up getting a 13% discount across the entire year. It's a win for you. It's a win for me. It's probably a win for Patreon. Who knows? But I really rely on listener support because I am an independent podcast. So if you have anything to throw my way and you like Pale Blue Pod and you want us to grow, then I would super appreciate you doing that. But if you can't support me financially right now, I totally understand. There are other ways that you can help the show grow. Actually, the best way to get Pale Blue Pod new fans is to share a link to a specific episode with someone who you think would enjoy it, because word of mouth recommendations are really powerful. So thank you for listening, first of all, and thank you in advance for any further support you can give Pale Blue Pod. All right, Chris and Buzz are back. I told you it was a quick little hop to the ISS, so let's continue this conversation about TRAPPIST-1. So this less magnetically active star is about 12 parsecs or 40 light years away. So it would take light 40 years to get from it to us. When this whole system was first announced in 2017, I went on to talk about it on a live news program on MSNBC at like 4:30 in the morning. It was way too early. And while I was there, I was talking about how far away it is. I said it's 40 light years away, and they asked me how far away that is in miles. They asked me to do a live unit conversion at 5 a.m. on TV, which was awful. I spit out like, I don't know, like 10 billion miles? No. I was at least like 10,000 times off.
I mean, how dare you? How dare you?
I actually felt really bad, Chris. I looked it up afterwards and I felt so guilty. I like issued a retraction on Twitter. I thought that people would really come for me. They just heard big number.
I was going to say, do you think any of who was the interview with? Was it Matt Al?
No, it was like their Morning Joe people.
Got it. I mean, do you think they had any idea anyways? You could have said, pie. You could have said pie. They'd be like, oh my God, that's so interesting.
You're so right. I didn't know that at the time. I took all of the pressure of getting everything perfectly right on my shoulders, and I felt terrible afterwards.
I mean, I think that's probably what makes the difference between you and I, and where you've gone, intellectually, and I'm sitting here and a child's playroom and talking about something I have no idea about. So
yeah, well, you'll probably have a lot fewer ulcers than I will throughout life.
Fair enough. Fair enough.
For the record, 40 light years is actually 250 trillion miles for anyone out there who wants the actual big number.
Okay, I have a question about light years before we go on. But again, I might have been fooled by the internet here, but I read something. I was also on a gummy at the time, so maybe I was just fully ready to be tricked. If I hypothetically had a telescope that could look 100 light years away,
yes,
would I see things that were happening
100 years ago? Yes. 100%.
You would?
Yeah.
Oh my God, that is the coolest thing I've ever heard.
Mm-hmm. Astronomers are basically time travelers.
Oh my God, I love that so much. Mm-hmm. I love that that's true.
Yeah.
Okay.
Yeah, it's really cool. Okay, so the TRAPPIST telescope, it's an acronym. We love acronyms in astronomy. It stands for Transiting Planets and Planetesimals, which are like tiny little things that are almost planets, then small telescope. So it's a small telescope that's looking for transiting planets, and it came online in 2010. It's a 2-foot telescope. So the main mirror is about 2 feet across, which is a pretty decent size. Yeah. It's on an observatory in Chile, on La Silla Observatory. I've been there. It's gorgeous. I saw my shadow cast by the Milky Way around there.
That's stunning. That's good stuff.
And it's operated by the University of Liège in Belgium, and they have partners with the European Space Observatory and the Geneva Observatory in Switzerland. And for 6 years, it operated looking for planets outside of our solar system. Didn't find a single one For 6 years, nothing. Until 2016, when a team that's based at the University of Liège in Belgium found 3 planets around that tiny little M-dwarf star. And they were really excited because it seemed like those 3 planets were the right distance away from the star to be habitable, like they might have liquid water on their surface. So they planned a bunch of follow-up observations. And later that year, they used the Spitzer telescope, which is a telescope out in space that operates, or like it looks in the infrared part of the spectrum, so just below what our eyes can see.
Okay.
So they looked at the infrared data through the Spitzer telescope, and they ended up finding that there were 7 planets in this system and not just 3.
Let's go. Let's go.
Very exciting. This was so exciting that it was actually put under a press embargo. This is something that astronomers do when they have a really big finding. The press isn't allowed to say anything about it. And the researchers on the team aren't supposed to say anything about it to like other people either. But Chris, astronomers are such messy gossips. We cannot keep a secret. So
spill the tea.
It might have been like illegal for people to talk about this, but I knew that we had discovered 7 planets in this system at least 2 weeks before the press embargo was lifted.
You were ahead of the game.
I was ahead of the game.
You know.
It feels
How
really
did
good.
you keep that secret?
Well, no one I knew cared.
Fair enough. Fair enough.
All of my astronomy friends, they were the ones who told me about it, and we would talk about it in hushed whispers in our classrooms. And then I would go back to hang out with like my non-academic friends, and they truly could not have cared less.
Like, shut up, nerd.
Yeah, pretty much, which is what I get for liking to hang out with artists and comedians.
Fair enough. Fair enough. I get it. Like, so how many years did you say from when they had or built the telescope to when they found something?
6.
6 years. Were they getting a little hot under the collar? Were they thinking about, are they gonna, shut us down? Like, what's going on? We're embarrassing ourselves here. Like, what's going on?
They must have. I mean, it was a relatively small operation. They had a bunch of people working together and contributing funds, so it wasn't that expensive for any one group. So I don't think it was in danger of being taken down, but there were probably some grad students who were relying on this data and really wanted to find exoplanets.
Yeah, I mean, I'm just like, I start to feel uncomfortable if there's like silence in a conversation after like 4 seconds. So I'm like, if I'm thinking 6 years, I'm like, like what's going on here? Yeah, so
this is why it takes observers a lot longer to finish their degrees than like theorists or people who do simulations or something. Sure. I was really lucky. I only used data that was publicly available online. I didn't have to wait for any observations to be taken. So I got through in about 5 years. But people waiting for this, it would have delayed them for sure.
Awkward, uncomfortable. Yeah.
So like I said, we know that TRAPPIST-1 has 7 planets in it. About 3, maybe 4 of them are in the habitable zone, and I'll get into what that means. But I do want to point out that this is not the planet system we've found that has the most planets in it. It is not a record breaker. The record holder is Kepler 9d, which is much further away, but it's still in the Milky Way galaxy, and it has 8 confirmed exoplanets in it. So at least as many planets as our solar system. Yeah.
Per Pale Blue Pod's official standing, that Pluto is not a planet.
Actually going against Pale Blue Pod's official standing, because Pluto would be number 9.
Wait, so are you pro or anti-Pluto?
I'm pro Pluto.
Oh, I thought you were anti. I'm sorry. I had it mixed up. My fault. I am also pro Pluto, for the record. I know everyone's asking, everyone's wondering. I would like to make an official statement. I am pro Pluto.
You heard it here first, folks. Yeah, yes. I understand what the criteria are, and by those criteria, sure, it's not a planet, but it's a dwarf planet, and that it's just a special planet.
Just let it live. Just let it vibe. Yeah. It's just out doing this thing.
It really is. The TRAPPIST-1 system was discovered with a method called transit photometry. Have you ever heard of this?
Of course. No, I haven't.
Of course. This is, you're about to see how much of a nerd I am. This is my absolute favorite way to detect planets outside of our solar system. My favorite space mission ever was the Kepler spacecraft, and they were built around transit photometry as a method. So here's transit photometry for you. Imagine you are a telescope and you're staring out at a patch of sky, and you are constantly measuring how much light you get from all of the stars in that patch of sky.
Okay.
If a planet happens to pass in front of one of those stars from our point of view, which isn't guaranteed because space doesn't owe us any sort of favorable orientation. But if it does, then it would block some of the star's light. And we would actually read that through our telescope as like a dip in the light curve. And we can study how much light was blocked and how long the light was blocked for to learn really cool things about the planet, like how big it is, how fast it goes around its star, and how far away it is from its star, which then lets us kind of estimate an average temperature. We call this the equilibrium temperature of the planet. How hot would it be if it was just taking in all of the warmth and energy from its star and then re-emitting it as heat?
Okay. And is this all in the end goal for getting an idea of if planets are habitable or not?
100%. Yeah, that was explicitly the mission here. Astronomers have for decades been obsessed with finding habitable Earth-like exoplanets. And when we say habitable, usually what we mean, because we can't often get a look like inside the planet or usually even at its atmosphere. So all we have is like a rough idea of how hot it is. What we're looking for is the right temperature range for the planet to have liquid water on its surface. So we define the habitable zone or the Goldilocks zone around a star as the distance range where like any closer and the water would evaporate away and any further the water would freeze.
Okay. Kind of sounds like what I used to do on like my online, like my Tinders and my Hinges. I kind of, made the pictures a little sketchy because just to see, people couldn't know exactly how hot I was. And that's how I met my wife. So here we go.
So it worked.
Yeah, absolutely.
So you're trying to put yourself in like the sweet spot of
like maybe maybe I'm just like I have my hand not like kind of over my face, so like you can't tell the whole picture. That's beside the point. So basically, their telescope was on this zoom right now. They would be looking if I did my finger like they would be looking for something like this, like a little swipe.
Exactly.
Wow.
Yeah.
Wow. That is enthralling work. It sounds like.
It is. It is. And what you want to see is like multiple swipes in a row, because then you can count how long it takes it to go in one full orbit around the star.
Okay.
Yeah, and then we can do a lot of fun math with that. And we've looked at the light curves from all 7 planets, and it was a lot of really complicated math to try and tease apart the light curves, because sometimes multiple planets are transiting at once. So you could technically see a dip from 2 planets at once. So you have to do a lot of careful math to separate those signals. But once they did, they found that there were these 7 planets, and we actually have some good characteristics for them.
Let's hear them.
Yeah, I will tell you about all 7 planets, but I kind of want you to, as you hear them, tag them as one of the 7 dwarves. Are you familiar with the 7 dwarves?
Oh God. I'm gonna need a list in front of me.
Or is there another thing that's in a group of 7 that you know really well?
No. But let me bring up a list of the 7 dwarfs on my phone, and then we can do it like that.
Cool. Yeah, I have. So the 7 dwarfs, there's Doc, Sneezy, Grumpy, Happy, Bashful, Sleepy, and Dopey.
Yes. Got it.
Originally, I was thinking maybe you could name all the planets, but then I saw a meme about Snow White, and I was like, no, let's do the 7 dwarfs.
I love it. Yeah, let's do it.
Awesome. Okay, so keep in mind, this entire system is so small. The star is about 10% the size of our sun. So the entire system could easily fit within the orbit of Mercury here in our solar system. Actually, it could fit inside Mercury's orbit 4 times.
Wow. So this is just a really little guy. Just
a little guy. Everything's so close together.
This sounds really cute. Just a little cute guy.
It is. Okay, so let's talk about the first planet from the star. We call this TRAPPIST-1b, and that's how we designate them. It goes, the star is A, and then the first planet's B, and it goes out from there.
Got it.
So TRAPPIST-1b is pretty Earth-like. It's just a little bit bigger. Gravity is about 10% stronger. It orbits only 1 million miles away from its star. It's so close. For the reference, Earth is 93 million miles away from the sun. So very close. And It takes only 1.5 days to do a complete orbit. And based on our models, it seems like the temperature at the surface should be 450 degrees Fahrenheit.
Ooh, okay.
Yeah. Yeah, pretty
Okay.
hot. Which dwarf is that?
I mean, that sounds like a pretty good existence, so I'm gonna go happy.
450 degrees sounds like a happy existence to you?
No, I mean, I do love Arizona. But I mean, like it's kind of Earth-like, potentially it's inhabitable. Like it's kind of just doing its thing. Like, I mean, I don't know if it's not happy. I guess it would be. I mean, 450. Well, see, that's the thing is you give me the 450 degree, and I don't know where that's going to end up on the scale of all these planets.
This is hot. It's
Okay.
probably the hottest planet in the system.
Okay, then that changes everything. Let's go. Let's go grumpy. We're gonna totally flip it on its head. Let's go
That's what I
grumpy.
thought you would say, and you came out with happy. I was like, I'm not trying to yuck your yum, Chris, but okay.
I try to keep it light. I try to keep it light.
You do. Okay. Then let's move out to planet C. This one also slightly bigger than Earth, and a lot of scientists compare it to Venus. So they talk about how, it's the right distance. It's also the second planet from its star, so it could maybe have liquid water on its surface. But based on what we've seen about its atmosphere, it probably is very, very hot. They have studied it, and it's about 1.5 million miles away from its star and takes 2.4 days to orbit. I think that if I were personifying these planets, I feel like planet C would have this weird complex with planet B because it's almost just like planet B, but a little less impressive in all the categories.
I think with that description, that sounds like a dopey planet to me. That sounds pretty dopey. Not gonna lie.
Yeah,
And
it does.
not dope, dopey.
Right. Like it's bumbling around like, oh, hey guys, can I be in the group?
Right. Just kind of, the fringe guy of the group. He's kind of there. Like you don't really want him there, but he always ends up there. That kind of stuff.
I like that. Planet D is one of the least massive planets we've ever discovered. Its gravity is less than 50% the gravity at the surface of Earth. It orbits 2 million miles away from its star. It does one orbit every 4 days, so it's pretty fast. And it's the first planet that we think it might be habitable. It's on the inner edge of the habitable zone. Even though it's so much closer to its star, because the star is very tiny, it gets about 4% more starlight than the Earth does. And it is probably too small to actually be habitable because it probably can't hold on to its atmosphere. So it's probably just like a naked chunk of rock that is, a pleasant temperature.
Okay. When we're talking rocks, I prefer my rocks naked. This is bashful, right? This has to be.
Ooh.
Just a little guy, I was like, I don't know if I have you guys, I don't know if it'll be a fun time. Like, I don't know if I can, host very well, like, might just be lame. Like, it's bashful. He's a bashful. Yeah, I think that's
you're good at this. I like this. Okay, yeah, that's totally the bashful planet. Okay, we're halfway through the system. Planet E is slightly smaller than Earth. It orbits 2.75 million miles away from its star. It orbits every 6 days. And this is the planet in the system that we scientists think has the best chance of being habitable. It's very Earth-like. The temperature's just right. We think it's big enough to hold on to an atmosphere. So what do you think?
I'm torn here. I think because there's been so much intellectual approval put on this guy, it's got to be Doc.
Yes.
Yeah.
That is the correct answer. I didn't plan correct answers before this, but that's
it. It feels right. Yeah, feels right.
It's the most accomplished. It's the overachiever of the group.
For sure.
Love that. Okay, Planet F is a little bit bigger and a little bit less massive than Earth. And when you combine that, it has a slightly weaker gravity, about 85% of ours. It orbits 3.5 million miles away from its star every 9 days. So we're, at least starting to get over a week in terms of the length of the planet's year. It gets 1/3 the amount of starlight as Earth, so it would be pretty dark and pretty cool on the surface. But if it has an atmosphere, then it could probably be habitable because atmospheres are really good at holding in heat. So especially if it has like volcanoes and stuff, then there could potentially be life there.
I mean, this is sleepy. This is pure cut sleepy. A little decreased oxygen. Maybe you're yawning a lot.
Mm.
It's slow. It's sleepy. It's kind of a dud. I don't like this guy. I'm out. I'm out on this one.
Oh, you don't like it? I feel like Sleepy and I would get along. I
Yeah,
too like to
yeah.
nap.
I mean, I do too. I do too. That's fair. That's fair. This seems like a dead planet, though. I'm out.
You're right. You're right.
Yeah.
But Sleepy is totally on track because it's so dark and dim. It's like twilight all the time there. Like
Mm,
I wouldn't be able to stay awake. Are you kidding me?
yeah, for sure. I mean, it sounds great, honestly. I gotta take it back, but I'm sticking with Sleepy.
Sleepy's good.
Yeah.
So we have left just Sneezy and Happy. So let's see how this
Ooh.
gets doled out.
Okay.
Planet G is the biggest planet in the system. It's 13% bigger than Earth. It's 30% more massive than Earth, so gravity is quite strong on the surface. It orbits 4.2 million miles away from the star, and it takes about 12 and a half days for it to complete one orbit. It is just outside of the habitable zone as we have defined it. So unless it has a lot of heating mechanisms going on inside, like volcanism and tectonic plates, and unless it has a thick atmosphere that can hold in heat, it's probably not habitable, but the optimists will say that it is.
Hmm. I think as a long-suffering allergy survivor, I'll take any thoughts and prayers that you're willing to send.
Hmm.
This has to be sneezy, uninhabitable, awful environment. Waking up, red eyes, sniffly, your throat's scratchy. It's sneezy. This is
Hmm.
sneezy.
Yes, it
That's
is.
what it is. Yeah.
Oh, yeah, bigger planet just means more allergens.
Yes, 100%. I couldn't take enough Claritin to,
No,
to to be on this planet.
really couldn't. Okay, the final one. We do only have one left, but you now can decide if you actually want to name it Happy or if you think that like we should just shut the whole system down.
Okay. Okay.
Planet H is the smallest in the system and it's the coldest. It orbits about 5 million miles away. It would take, like in the teens days, less than 20 days to orbit, but still longer than all the rest. And this planet's claim to fame is that Hubble Space Telescope has studied it. And it's possible that this planet has a lot of water, but it would be in ice form.
Mm. I did just profess my love for a 450-degree planet. So a very cold planet would probably not make me very happy.
Hmm.
But I mean, it sounds like it's gotten its due. It's gotten its flowers from the
Hmm.
world of science. So I think happy is applicable here. I think
Great.
that sounds like a happy planet to me. It's feeling seen.
Yeah.
So I think that planet's in a good space. I think that's happy.
Yeah, I like it. I'm picturing this like very small, happy-go-lucky planet. It's the fastest planet in the system, just like going around out there.
Yeah.
Actually, it would be the slowest planet in the system, but it is moving the most distance. So I'm imagining Planet H out there just going like wee as it
Yeah.
orbits. Yeah,
Yeah, vibes are high. Vibes are high, and it's Planet H, so it's happy.
it's happy.
It checks out.
It's almost like it was meant to be.
Yeah, absolutely.
So we are very interested in this system of planets. We haven't found another system that has so many potentially habitable worlds in it before. We think that probably many of them have ice on the surfaces based on our study of the like molecules that we see coming in their atmospheres, but we have to study them more. And one tool we're going to use that is JWST, the James Webb Space Telescope, or the Just Wonderful Space Telescope, if you would rather not use the official name, because there's some like history stuff there.
Oh, okay.
But
Was James Webb the one that came out with all those super sick pictures like a year or two ago?
yeah,
Okay, yeah, I was way into that. Those are so
they
awesome.
were gorgeous. And
So cool.
like the pictures get a lot of attention because JWST has amazing cameras. But JWST also has amazing spectrographs. And these don't take pictures, but they can take light in and split it up into all of the different wavelengths and measure how strong the light is at different wavelengths, which tells us some information about the molecules that the light had to pass through to get to us. So
Okay.
JWST also released a beautiful spectrum of an exoplanet showing that it had water vapor in its atmosphere. And the public didn't really care about that, but the astronomy community was so excited.
Freaked out. Big
Yeah.
day. Big
Yeah, they
day.
did. They were like, "Oh, you see those little hatch marks on that graph? That's so exciting." And
Hatch marks. Love a good hatch mark.
don't we all? And the JWST is going to do the same thing for the TRAPPIST-1 planets. It's really good at seeing smaller, thinner atmospheres than other instruments we've had before. And so all of these planets have relatively thin atmospheres. They're not very puffy. They're not like the gas giants in our solar system. So we need a very strong instrument like JWST to study them. And it has done some observations, but more are coming up. So hopefully in the next couple of years, we'll have more information about like real habitability details for planets D, E, and F.
Okay, yeah, I was going to ask what kind of time frame are we working on there, but I mean, I would assume this is probably not a rushed process. Yeah,
No, science moves pretty slowly because we want to be careful with our data.
yeah,
Honestly, the data has probably already been taken, but it takes time to go through it and analyze. So I would expect a year or two after the data is collected that we would get a result.
okay. Okay. So do you kind of in your, circles that you run in, are you generally getting an idea of what the data is telling you a little bit before us normies,
Ooh.
us normal dummies are getting? I'm not asking you to betray any confidences
Right.
here. I'm just, let's talk around it.
Of course, of course. Yeah, I'd say when I do spend time with astronomers, we love to talk about our work. And I will hear if they're working on something particularly exciting, like I will hear their breakthrough before the press does. That's why I really like going to conferences because you get to talk face to face with astronomers and hear them brag about weird things that they've discovered that they haven't told anyone yet. Because I don't do research anymore, but my favorite moment when I used to do research was that like 5 minutes after I saw something in my data before I told my advisor when I was the
Mm,
only person in the world to know that thing. And
yeah, that's sick.
yeah. And then scientists love to ruin it by telling everyone they know
Of
immediately.
course. Blabbermouth. Lots of
Yes.
blabbermouths over there.
We really are. So yeah, I think that should be really encouraging, actually, that astronomers cannot keep secrets from each other or
No,
other people.
yeah, yeah, you can't hide it from all of us dummies.
Yeah. So, if there are aliens, astronomers don't know about them because we
Okay.
we couldn't keep it from you.
So, do you think there are?
I think there are, but I don't think they've come here. And if they have, then they're really good at evading the astronomers.
That's fair. I mean, there's literally no way that there's not any other living being
Yeah.
anywhere else. Like
Yeah.
this little shit can planet we're on, like there's no chance that this is it.
I
There's no way.
agree. There are several hundred billion planets in our galaxy alone.
Right, right. It's a numbers game at that point.
Yeah.
Okay, good. Well, I'm glad that I think, similarly to what the smart people think on that.
Yeah, we're in line. That's all I had about Trappist. Do you have any lingering questions about anything?
No, I mean that was wild. I'm very interested to see what our not. I was about to say our boy James Webb is going to tell us, but he's. It sounds like he's not our boy.
Well, the telescope, the
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 telescope
Jelly
is
Welly, as some
Jelly
people call
Wally,
it.
J Dubs,
There
J
you go.
Dubs.
Yeah, that is going to give us such a beautiful view of these planets' atmospheres. And one of my projects in grad school was trying to understand the inner mechanisms of a planet by looking at how it could form mountains and other surface features. But even when I did that project, I knew we wouldn't have the ability to study that type of data for another decade or two. And JWST is one of these first, like, really powerful telescopes to come along that's solving that same problem for people who were in grad school the decade before me, where, like, they were coming up with methods that couldn't be applied until we had the right tools. And now James Webb is out there doing that.
Our white scientific knight.
It is. It's it's definitely a savior telescope of some sort.
Yeah, that sounds great.
Hmm.
Yeah, this was dope. I might just have to dive a little bit deeper, as we go on here into
Awesome.
our dear friend Trappist.
That is music to my ears. Before we go, though, I would love for you to take some time to brag about yourself and let us know about anything you're working on and where we can find you online.
It's one of my favorite things to do. Love bragging about myself. I can be found on all socials at Chris Cook 2. I also run a sports slash pop culture ish blog. It is called Untimed Down. Can be found at untimeddown.com. Two D's in the middle. And we're on Twitter, Instagram. I'm too old and dumb to understand TikTok. I just swipe it. I don't post on it. Yeah, we're on Twitter. I'm still calling it Twitter. Again, we'll take another shot across the bow at Elon. I'm calling it Twitter until I get off, until I understand what blue sky is. But yeah, find me there.
Those links are all in the show notes.
Perfect. Yeah, I would love to connect, interact with anyone who wants to chat.
Woo! All right, listeners, you heard it. Go check out Chris's links, check out the blog. And I think that Buzz wants to play some games. I think we should let Buzz free.
Let's do it.
Well, everyone to infinity and beyond.
That's right.
No matter what the highest number you can count to is, for me, it's definitely not infinity. You're still space.
Absolutely.
Pale Blue Pod is hosted by me, Dr. Moiya McTier, aka the universe's bestie. I created the show with original co-host Corinne Caputo, a comedienne extraordinaire, and help from the Multitude Productions team. Our theme music is by Evan Johnston, and our cover art is by Shay McMullen, and our audio editing is handled by the incomparable Misha Stanton. I am Go Astro Mo everywhere online, and you can stay in touch with the show and the universe by following Pale Blue Pod on Instagram or checking out our website, palebluepod.com. We are a member of Multitude, an independent podcast collective and production studio. So if you like Pale Blue Pod, you will love the other shows that live at multitude.productions. And if you want a shout out on the show and research notes for every episode, you can join our community over at patreon.com/palebluepod for just about $1 per episode. Thank you so much for listening to Pale Blue Pod. I'll be back next week. Bye.